Computer Programming Essentials, Unit 5, Part 1. In this unit, we will go over Chapter 4, only part of Chapter 4, so be sure that you use these slides as your guide and use them as your guide when you are reading the textbook, and make sure that you focus in. It's designed to provide you some focus on zeroing in on what's really important. There are parts that we skip because they are not part of our course objectives. So in this chapter, we are going to look at understanding blocks and scope. We're going to learn how to overload a method. We are going to avoid ambiguity and use automatically imported pre-written constants and methods. A code block is denoted by an open and a closing curly brace. You can't have blocks that overlap. You can have a block within another block. So you can have an outside block or an outer block that contains one or more inner blocks. We call this nesting, and if you think of those Russian dolls in which one is completely nested inside another, this gives you an excellent example, an excellent visual of how code blocks work. Here's an example in code. Public static void, method with nested blocks, and notice the open brace underneath the P in public that marks the beginning of the outer block. If you scan with your eye straight down, you'll find the closing brace for the outer block. We like to indent open, and we like to line up open and closing braces and to indent all the code within them, because it makes it easy for us to see where a block starts and stops. I encourage you to follow this indentation style. In fact, it will be a large portion of your grade for your programs. Notice the inner block, where the inner block starts and the inner block ends, and everything inside that inner block is indented another level. Typically, you won't see an inner block that's just thrown in there willy-nilly. Typically, there will be a logical reason for it, and we'll learn those in the coming unit. We'll have an if statement or some kind of loop that will cause us to need an inner block. This inner block is just thrown here to show you an example of variable scope. And you see that inside the inner block we declare a variable called another number, set it equal to 512, and then we print it out. When the code block ends, another number ceases to exist. It goes out of scope, and we say that its lifetime is over. The lifetime of the variable another number is no longer exists. So when you declare a variable, it is available from the point in which it is declared until the end of the code block in which that variable is declared. Scope refers to the portion of the program in which you can access a variable. A variable comes into scope when it is created, and it goes out of scope at the end of the code block in which it is created. You cannot redeclare a variable with the same name in the same code block. This is illegal, and your program will not compile. For example, take a look at this code where we've got int a value equals 35, and on the next line we say int a value equals 44. You can't do that. You've already declared a value once. You cannot declare it again. You could give it a new value. You could say a value equals 44 without preceding it with the data type. Preceding it with the data type means that you're declaring it, not just using that variable. And notice inside the inner code block we try to do that again. Int a value equals 10. That won't work. We could say a value equals 10, but we can't say int a value equals 10. Overloading a method. Overloading means that you are using one term to do two different types of things. An example that we've seen so far is the plus sign. The plus sign can be used to concatenate two strings, or it can be used to add two numbers together. We can do the same thing with methods that we write. So we can write multiple methods with the same name, but in order to avoid ambiguity, in order so the computer can tell which method we want, if we are writing a method with the same name, it must have different argument lists. So methods with the same name must have different argument lists. The compiler understands the meaning based on the arguments used within the method call. So if we name a method tiddlywinks and it accepts one integer parameter, if we name another method tiddlywinks, it must have a different parameter list. It could accept a double parameter, it could have an int and an int, or a double and an int, but it can't just have one int, because then the compiler wouldn't be able to know which one we wanted. Do you want this tiddlywinks or that tiddlywinks? It's ambiguous. Here's an example of overloading a method. If we have a method called calculate interest and we pass 2 double parameters, we could write another method called calculate interest but only have one parameter or have parameters of different types.